Hello, my name's Paul Withers, and I'm here talking about scheduled processes on Domino. Now, we know how we've always done them for years. The way is to go into the agent area in Domino Designer, create a new agent, typically as Lotus script, because that's where we've typically had all our skills. More recently, sometimes we may have used Java, and then in the agent itself, and in the agent properties, uh, go into the area at the bottom here and set it to run on a schedule and schedule it however we want it to run. And that's stored in the design. If you've used any third-party tools, something like LEI, Lotus Enterprise Integrator, or Notrix, then that can store those schedules separately. It can store the authentication for them separately, and the agent just sits in Domino Designer as a scheduled agent, but not enabled, and it's just kicked off externally. The downside of that, as we've moved into X pages, or as we move beyond that, is that we can't reuse the code that we use elsewhere. So our X pages code, which might be in server-side JavaScript script libraries in here, for more advanced developers, as they've moved beyond server-side JavaScript, it may typically be in Java classes accessible in Package Explorer, for example. But your scheduled processes, the agents here, can't reuse any of that. They can't reuse packages that are on OSGI plugins, things like openntf-domino-api, for example, or Apache Poi, in Poi for X pages. If you wanted to use those, then it starts getting more complex to use those in a scheduled process. In the 9 years now that X pages has been around, it's a problem that has never really been solved, but it's one that has always been nagging away at me, particularly as I've moved towards coding more in Java and not really keeping my Lotus script skills up to date, because I'm just not using it regularly. So I've always been looking for a smarter way of doing that, and a way to actually reuse the X pages code that I've written. And I've finally come up with one. What I've got is a demo application, which you can download, install, and walk through to see how it's doing what it's doing. It's up on GitHub. So if you go to my GitHub area, and it's under pull list with the scheduled ZOTs, then all the source code is there, and documented as well. One of the other options that I've forgotten was dots. It works. Scheduling isn't quite as straightforward. It's in a separate memory space from the X pages code. The OSGI plugins are in a different area, so kind of reusing a lot of that is more difficult. So the approach that I've come up with is using X agents or REST services and Node-RED. So, as I said, we've got this demo database, scheduled ZOTs demo servlet. What you install is just the OSGI plugin. You don't have to install any databases as such. Those will all get handled in the deployment. So once you've installed that, signed it, restarted HTTP, then you're ready to go. So here it is on my server. And to access that OSGI plugin in order to do all of the setup, it's using REST services. So it's at a root scheduled-zots-demo, and the setup code is at a further endpoint setup. There aren't any additional path parameters for the GET request that handles all of that. So scheduled-zots-demo setup, and this goes off and deploys everything to your server, signs it, and as we can see, creates 400 users. So let's just step through that code for a start. It's using ODA. Everything that I code nowadays uses ODA. It just makes so much sense. It's using server session, and it's if there are any databases already in the path that it's installing them to, it removes them. It then gets a resources stream, this NSF that's sitting in the plugin, and creates the directory structure and creates it at a particular path. So the folder that it's putting everything into is openntf-demo. The file name for the live database is scheduled-zots-demo.nsf. For the archive database, scheduled-zots-demo-archive.nsf. So we're creating two databases. And I would just wanted a simple piece of code that could be called from a UI, but could also be called from a scheduled process. So what I'm doing is basically an archive process to copy X number of documents from the live to the archive and remove them from the live. So in order to do that, I first have to set up the databases. I'm also signing it with the server ID. Database.sign only works on a workstation. It's something that we've got in ODA, but probably really doesn't make much sense having it there, because most people will be using ODA on a server. Administration.sign with server ID is another option, but that seems to throw errors. So I'm getting all of the design elements as a note collection and iterating through them and signing them. You'll notice that on the REST service here that I was calling, I'm not authenticated. So the first thing that I need to do is set up the ACL and give anonymous editor access. And I'm then copying the archive database. Then I'm calling an X agent in that live database to create 400 users. We'll come back to that X agent later in the video. But I'm then locking down anonymous access. So if we go into the actual databases themselves, so openntf scheduled zots demo, I'm actually logged in here as an admin user, but if I hadn't been logged in, let's just log out of that and go back in, then you'll see it's fully restricted for authentication now. So we've got 400 documents there, and if we just look at the archive, then that's just a blank database, and it's a slimmed down version of the extension library demo database. So what we've got is some code on a button here, archive selected, that's copying documents across to the archive. Let's just have a look at that code first that's in the UI. So it's the context view, archive selected is calling a Java class. All my code now is Java, so all you'll ever see on the X pages is just a single line, typically in server-side JavaScript. All of my code here is here, which is much more user-friendly and easier to work with. So it's calling an archive doc method, which is again a simple piece of code that I can use from wherever, that creates a document, copies all items, and then deletes the document. It does mean that it has a different ID, but if I remember correctly, it's actually quicker than copy document. But of course, it means that you've got a different created date and ID. But for this, that's not an issue. So that's the setup and what's happening in the UI here. What about scheduled processes? Well, for that, as I mentioned before, I'm using Node-RED. So Node-RED, if you haven't come across it, is it was initially kind of designed, I think, for Internet of Things, but it's basically low-code, drag and drop process flows. And one of the aspects there is calling REST services, and one of the other aspects is scheduling. So it's perfect. It can run locally. It can also run on Docker. It can run up in IBM Cloud, as it is now. It can run wherever. Installing on Windows, very straightforward. We just install Node.js, install Node-RED, and then we're good to go. It's also possible to be installed as a Docker image. And again, this is very straightforward. The one thing to bear in mind with installing it as a Docker image is that it's in its own separate container. So even though it's, I could install it as a Docker image on my PC here, localhost, as far as it is concerned, is the Docker image, the Docker container itself. It's not the host PC. I can use the server name, server URL that I use here, but again, it doesn't understand where to find that. So what you then need is some way to map between those. And the one that is the obvious one to use is ngrok. So for that, for example, you download, install that, then go to the relevant location, and ngrok, whatever service it is you want to make available externally. So it'll be available from anywhere, and what port to expose it on. So here I'm exposing my Domino server, and now from absolutely anywhere in the world, people can use an HTTP URL or an HTTPS URL to access my Domino server. And when I was doing my session with John Jardine at IBM Think, at one point early on in the development, he was working in South Africa, interacting with the Domino server that's running on my PC here, using ngrok. It's a very good tool. Once you've finished with it, then Control-C here will shut it down, and that address is no longer available. If you want the address to persist, then you need to look at one of the paid offerings for ngrok. So Node-RED is very good. It's very widely used. one of the places that's using it is Agility, and if you look at Agility's homepage and then onto the blog, then you'll notice that Agility is our good friend from the community, John Jardine. It's been around, it's been used for a few years now. It's extremely powerful and extremely good to use. But I'm actually running it here on Windows. So it's just a case of going to the Node.js folder, and as it says, checking the npm version, which that comes back with there, and the Node.js version, Node version, I think it is. Yep. And then running this install command here. With Windows, there's a bit of a quirk there, that it's installed in app data. So there's some documentation there on how to get around it. But once that's all set up, then you just run node-red from anywhere on the command, and it starts up. It's up and running and on port 1880. So if we go to that, then this is what you see. You see a drag and drop area. You won't see any flows on yours once you've just installed it. I've actually already got my flows set up, but they're also on the GitHub repository in the Node-RED flow folder in flows. And if I just open that up, you'll see it's just JSON data. And one of the aspects there, as we drill down, is that it's including a URL. Of course, because this is JSON, we can just do a find and replace on that part of it. And run a replace all, and then that's ready to be installed into your Node-RED version. Just go to, just copy it all, go to the menu, import, clipboard, and then just paste the JSON there, and import, and you're ready to go. So it's very easy for deploying across environments. It's very easy for picking up and moving around and sharing with other people. It just makes so much sense from so many for so many situations, really. So what have we got here? Well, we've got this inject node. So with any of the nodes, then you get this help here, and you'll see that you can set it to repeat. Here we've got it as it's running every 10 minutes. You could have it running at a specific time. So you could have it running at 4 a.m. every day, for example, or 4 a.m. just on a Sunday. If you want a more advanced timing, like you want it to run on the 1st of every month, then there's another Node-RED project called Big Timer, which you can install, which then allows some more detailed settings that can be done. So yeah, you can see we've got a bit more flexibility with those. So here I've just got it set to run every 10 minutes, but we've also got this little button here that I can click to kick it off manually. We've also got, so that's then chained to this HTTP request. The HTTP request is a GET. It's authenticated, as you see. So you remember that we lock down access to the database itself. Of course, we want to. So that's locked down. So we need to authenticate in order to interact with it. And here we're calling an X page, an X agent, and it's returning a parsed JSON object. So let's just refresh this to make sure that it hasn't run yet. Let's kick it off. And that's going to go through and archive a load more documents. So let's just have a look at that code. So that was the shed archive page here. It's a normal X agent. Remember, if it's an X agent, set view state to no state. X agents can't be stateful, so there's no point storing the state on the server. If you just entered your whatever code you've got on any standard X agent that you've used in the past here, you could kick that off on a process from Node-RED here, and it would run through and in real time, and at the end of it, pass back whatever it needs to pass back, whatever JSON object back to Node-RED. In this case, we're outputting it. We're outputting just the payload to our debug console. That's great as long as it's not a long task. If it's a long task, then you want it to run in the background. As I say, there we're getting the print writer. We're writing that message asynchronous task running, and because it's an X agent, that's then passing it back to Node-RED, which is what's calling it. But because I want to demonstrate running something as a background task, we're using this ZOTS. We're using ZOTS to trigger a ZOTS task. Now, ZOTS has been around in ODA for, well, must be at least 4 years. I've had it running in production now, and it just works. Think of it sort of like Agent Manager. It spawns 10 threads that can be run at the same time. So it can run up to 10 ZOTS tasks at the same time. And the ZOTS tasks are either runnables, which mean that they just go off and run in the background, or callables, in which case they are triggered to run off, and when they finish, they return something back for the calling code to be able to use it, hence a callable. You can define what session to use. So here it's cloning the current session. So because this is called from Node-RED with my credentials, it's running as me. An XSP scope just means that it handles, it sets up some additional objects around there for scope variables, for example, for outputting to openntf, openlog rather. Documentation for it, there's a fair amount of documentation and some examples on the OpenNTF wiki for ODA, and there's various blog posts that I've done in the past that go into it in quite a bit of detail. But with a runnable, all of the code is in the run method, and we see that it's calling this utils.archive-doc. So from a background task triggered from a scheduled process, we're actually reusing live code that we're also using from an X page. The one thing to bear in mind is that there will be slight differences in how you can handle error handling, for example. That's covered in my blog posts on how to do that. But other than that, it's fairly straightforward. As you can see, it's standard code that we're using there, and all that we're using to kick it off is zots.getService.submit new shed task. So that's running it from an X agent. Smart NSF has been around for a little while now, so we've got another flow here that's again set to run every 10 minutes. That is calling a smart NSF route X REST archive. Now, again, if you're running smart NSF and it's running and you're putting your code in there to run just like any other smart NSF route, then it'll just run inline and at the end return the result. If you want to kick off something else, then that's where you need this custom strategy, and you set up a Java class. So here we've got one called custom REST. And I've just basically copied the sample that is in their documentation on the OpenNTF wiki. It implements a custom REST handler, which has this process call method. They use JSON writer, which makes much more sense. It takes a JSON Java object, and as you can see, that's kind of like your scope variable map or any other Java map. So it's much easier to set up JSON and not make a mistake for it. It also allows us to set a status. So we're setting a 202 status here of accepted. And whereas before we were calling shed task, then here calling shed task non-XSP. Although Smart NSF, it sort of feels like Xpages, it's not actually running within the full Xpages runtime. So it doesn't have access to some things like faces context and those kind of things. So it certainly doesn't have access to the, I think it might have access to faces context. I can't remember the documentation fully, but it certainly doesn't have access to scope variables. And so it threw an error when I was trying to use just the same shed task, ZOTS task. So we just use one that's extending abstract ZOTS runnable with tasklet.context.default instead of abstract ZOTS XSP runnable with XSP scoped. Other than that, it's pretty much the same kind of code. Again, just calling archive-doc. So we can see that whilst we've been going through that, those two have actually kicked off. So we've already got quite a few more documents that have been moved across. We've got 4 pages left. Let's kick those off. Let's kick this one off with the smart NSF route. And we can see that that's now moved the rest of them across. So those are two options there with smart NSF and an X agent, which you can either run asynchronously with a ZOTS task or run inline from Node-RED and just return a JSON object to output here. The output option can go to that debug window. It can also go to the system console, in which case it would go into this bit here. If you do that, then the one thing to remember is it gives you this little blue circle on there to say that something is unsaved and undeployed. You need to deploy it again in order for that to be available. So that's calling an X agent and a smart NSF route. I just want to check what this is calling. Yes, that's the one that I want. So, of course, this is calling a REST service, and it can call any REST service. I've also got another REST service in the plugin, which is this chain reinitialize resource. And this has an endpoint of do chain. So what this is going to be doing is this is going to run this deletion task, which is going to delete all the documents from the two databases and call another URL, this redirect URL, which is what's been passed in from the REST service. So we're actually going to be doing some chaining here. Again, this is one that's could be scheduled. It's kicking off that REST service using the do chain. And you notice we're not authenticating this time. It's in the OSGI plugin, so it doesn't need to be authenticated. It could be, but it doesn't need to be. But that means that it needs securing in some way. Coming back to the agents that we had here, we've got this agent. You'll notice as you come across here that it's visible to the web. I could, if I know that it's that there's an agent there called test, and I know that it's !open agent, then with any authentication to the NSF, I can kick off that scheduled agent, even though it's only supposed to be run from a schedule. Obviously, it's best to kind of secure things a bit more. So what I'm doing with Node-RED here is I'm setting an app ID and an app secret, which is going to get passed in the headers of the REST service. Then over here in my not sure why that's not coming. There it is. So over here, I'm then checking that app ID and app secret against what the REST service is expecting. And if they're not, then I'm saying that you're not authenticated. You can't get in. So even though it's anonymous, it's tied down. It could be secured for authentication as well, which means that you would need to have a valid username and password and these keys in order to access it. But it just gives a bit more flexibility. Of course, there's no reason why you couldn't do the same kind of thing in an X agent. But this is just an example of locking things down a bit further. And we've then also got a redirect URL. So the redirect URL that I'm setting here is Node-RED, localhost port 1880 /API/XPages callback. And you can see that what I've got here is an HTTP node, again in Node-RED, so it's running on port 1880. It's a GET, it's /API/XPages callback. So that gets passed to the REST service in the OSGI plugin. That gets passed to this deletion task. After deletion, then we're creating an HTTP URL connection to that redirect URL, telling it it's got to be a GET. We can pass parameters across with it, and we're connecting to that endpoint. So we're calling this endpoint here, which will then call a generic X agent to load data with 800 users. And this is an X agent in the NSF. So we can start to kind of chain processes together. That starts to give a lot of power. So let's just show that running. So we've got everything in the archive, nothing in the live. So this is going to delete it from both and then populate the live. So we kick that off, and you saw that there was a little blue flash here as it came back into this part, and it's given us the message there of 800 users created. If we come across here, that's now empty, and that's now full. So it allows us to do a lot of that kind of complex chaining. I just want to come across to that generic X agent. Let's just close some of these other windows. So that's calling a generic X agent manager and do get. Now on this generic X agent manager, I could do some checking to make sure that the request was actually a GET request and not a delete or a POST request. I'm not. But what is happening here is I'm calling generic HTTP request utils dot initialize and process as JSON, and then I'm calling introducing a new callback. Let me just step back from that for a moment. What I've got in the generic HTTP request utils is some agents here, some methods rather. That's not the one. Initialize and process background task, that's the one. So what I've got on, what I had so far was that you needed to set up a ZOTS task. That starts to become a bit more complex. So I've looked to try and make it a bit easier. And one of those is this utils.process background callback. And this is where I'm using this new way of doing things, where it's using this generic HTTP request utils area. So you'll notice that there's no ZOTS task here. All there is actually what we've got here is a Lambda. in Java 8 functionality. But it's calling initialize and process background task. That takes a callback. This code then sets up the request and gets out at the query parameters from it, and then it creates its own background ZOTS callable runnable, passing in that callback as well as the parameters, and it kicks it off. The run method of that ZOTS task calls the callback that's been passed in. So that basically, by using this method, you're passing in a callback, that's being passed to the runnable. The runnable is then kicking off the callback, which is your custom code. It's something that's standard in Java, but it's not something that's really been used in domino code in Java very much. But what it means is that you can just use initialize process background task. If you're using Java 8, then you use map string params hyphen chevron and then your code. So that you can use that task, you can use that functionality so that all that you need to write is your custom code. The bootstrapping around it to allow you to get hold of those query string parameters is done for you. So it cuts down your code. It also means that you don't need to remember to call faces context.response complete or whatever it is at the end, because the bootstrap code is doing that for you. You just need to write your code. And that's what we're doing here. And it's the standard code that we've been used to elsewhere. The only difference being that we're getting a count of documents and only creating as many as there are there. I'm using a similar kind of callback from this generic X agent manager. What you're seeing here is the Java 6 style functionality, where you actually have to create a new XSP HTTP servlet JSON response callback, which has the process method, which here it's taking the request, the response, and the JSON object. And this code is then running inline in real time. But this is then much more generic, it's much more flexible, and you can have a single chunk of code that's handling multiple processes. So you'll notice that on this URL here, I was passing in what process it is, load data, and the number of users. So it becomes much more flexible. I could also have told it to run async, which means that it would have been kicked off as a ZOTS task, as we'll see further down, and it tells it to pass back a HTTP 202. But we're checking for a process in that URL. If that's not been passed, then we throw an error back, a bad request, an HTTP 400. Once that's if there is a process, then we start checking it, and at the end of that, the else bit says it's a process that we weren't expecting. Throw it back as an error. We're then checking for a user count. We're setting a default of 200, but if a user count is passed in, then we use that user count. If it's asynchronous, then we create a ZOTS task, this data initializer background task, where we tell it the process and the number of users, and we pass a message back saying that the users have been queued for asynchronous generation. Otherwise, we create them in real time and pass back the message that the users have been created, which is what we got here. So there's load data. Reload data will, if we just go into this data initializer, the reload data will we've got three options here. Here it is. Load data, reload data, and delete data. So if it's anything other than load, then we delete the data. If it's anything other than just delete, then we also create the users. So load will just create them, delete will just delete them, reload will do both. So we can start adding some greater flexibility there. And at the end, if we've hit any other error that we weren't expecting, then we send back an error 500. So we've got a much more rounded, much more flexible REST service here. But again, one that is being called from from Node-RED. But if you remember back to the setup, it's also being called from the setup. Just one word on ODA here. You'll see in the NSF here, I've got various methods that are set to be for ODA, and I've actually transferred some of that code into ODA. So if we just have a look there, then we've got XSP utils somewhere here. That's the easiest way to find it. Help us. XSP utils. So I've moved some of those across there. So the initialize and process response, which does that kind of bootstrapping, but it runs it inline. So that's more the kind of thing that is happening here. This code is set to run inline. And that then gives access to the request and the response. Because it's running in line, it makes sense to have access to the response because you're going to need to pass something back, as we are here. That's there you handle what's being passed back. It could be JSON, it could be plain text, it could be whatever. There's also initialize and process responses JSON, which again is running as inline. And if you haven't already set a response status, then it sets it to 200 at the end. You could already have set it to 202, to 500, to 404, 400, whatever, but that's just sets a default. In terms of asynchronous, there's initialize and process async. Now that there's obviously no point in giving you access to the response in the ZOTS task, because this ZOTS task is just scheduled and runs in a separate thread, so there is no response left for it to send to. So that only passes the servlet request. What it does mean is that this can't really be used for chaining, because or can't be used for chaining to automatically do the chain, because how do we get the URL and know what all the settings are going to be, to pass it in there, to pass it into the ZOTS task and do all of that setup for you. Over here with the basic ZOTS chaining one, we expected a redirect URL. We're expecting that it's just going to be a standard URL connection that's needed. It's not going to be an HTTPS. It's not going to go through a proxy, those kind of things. With something like ODA, it's much more flexible. You can't really make those kind of assumptions. So you're going to have to set up the HTTP connection yourself with this same kind of code. That's using java.net, which is okay in Java 6. It's not great. If you want to use something more robust, then I'd recommend using this an Apache HTTP set of classes, which is what we use in the Watson Workspace Java SDK. And again, that's well documented. Oliver Bousset has a blog post about it. Another option is OK HTTP, which is what the Watson Developer Cloud stuff is using. If I go into the reference libraries here, then you'll see it's got OK HTTP stuff, and that's another standard one. But whatever you use, sooner or later, you're going to need to be interacting with external REST services. So it's going to be something that you're going to get a degree of familiarity with. This is fairly basic and could be used. But if you're wanting something more robust, then the Apache library or the OK HTTP are ones to go for. So that's kind of covering all of the Node-RED side of it there. As you see, with calling those HTTP requests, with doing the chaining, we've got a visual UI. If you want to get an output of the schedules, then I Googled for Node-RED schedule, and because I was looking for other schedulers. There's one there, Contrib Lite scheduler. But I came across this as the first one, which is another Node-RED add-on that you can just add in that gives you an output of all of the inject nodes. So Node-RED is very flexible. If you haven't come across it yet, I would very, 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 very strongly recommend you look at it. There's some great stuff for dashboards as well. And with Node.js coming with Domino 10, really it's starting to become a no-brainer as something that you should be using for a variety of options. For example, there's also nodes for interacting. I think I've probably got it installed here, but things like Twitter, monitoring files. There's also ones that are available for Watson as well, for interacting with Watson work services and Watson conversation stuff. It's a no-brainer to really get involved with. And the ability to reuse your existing XPages code to easily interact with REST services if you're starting to develop apps outside of the NSF, like in my session with John Jardine IBM Think, then it just makes so much more sense to do your scheduling in Node-RED for that. And hopefully that's given you an introduction and at least the basics for even just calling inline X agents or smart NSF routes that are just running in real time to do business workflow on your applications. Thanks.